Hello, YouTube. This is Umozo3. In the previous video, we talked about two new concepts. We talked about something called pass by value. And we saw an example of a static method which basically accepted an input. And it seemed like it was going to do something to a variable, like add 1 to it or 2 to it or something like that. But then when we tried printing the result of the variable after running the method, it didn't seem like it got updated. We said Python passes information by value rather than reference. And then we also talked about some shorthand for set notation, right? So instead of calling a.union b for two sets A and B, you could just say A, and then you could have a vertical bar, right? And so we talked about shorthand notation. So we can review some of those concepts in this video, but I also wanted to review some concepts from previous videos like 68 and 69. So anyway, we have a class called concatenator, okay? And we have a constructor, so in it, and then it has one input, right? V, okay, so self, again, just signifies to Python that you have an instance method. A constructor is an example of an instance method, and it doesn't have to be self. You can call it W if you want, but then here in the body, you would say w.myval equals v rather than self.myval equals v. But anyway, I have some doc strings here. So if you scroll over the constructor, you would hopefully see some documentation, right? So it says constructor to assign a value to the myval instance variable. And then it shows you the input, right? So v, the value for the new concatenator object. So self.myval equals v. Okay, and then we have a class method. So a class method, again, you have to have this little caret here, but otherwise it works basically like a static method where you call it on the class rather than an instance of the class. So a class method which accepts a string and tries to concatenate text to it. You could print, okay, I'll try to add on something about pizza, right? You could have a string called X, and you could try concatenating on pizza is delicious. We could try running that in this video, but the point is that X would not be updated outside the context of this static method. That's what we saw in the previous video. And then we have this, so then let's go ahead, we can go back and forth, I think, between the methods that I wrote and like the codes and. So this is the input, this is what myval is going to be assigned to in the constructor that we were just looking at. So X equals concatenator of cookies and then Y equals subclass concatenator of pasta and. So then we're going to scroll up and we see that subclass concatenator is a subclass of concatenator, right? This is the notation in parentheses. And in lesson 34, we're talking about inheritance and subclasses and how that works, right? But then if you have basically the constructor of the subclass, so if you create a subclass concatenator object, what happens? Well, you still pass in a V, but we're going to basically call the constructor of the superclass, but instead of just passing in V to the constructor of the superclass, we're going to pass in hello and then V. Okay, so if you basically call Y equals subclass concatenator of pasta and, then myval is not just going to be assigned to pasta and, it's going to be assigned to hello pasta and. So hopefully that's clear to you. That's what the value of the instance variable would be, because that's how the constructor works in the subclass. So hopefully that's clear to you. And then print of t colon equals 400. So that's an example of the walrus operator. So not only does it assign 400 to t, but it also prints the value, right? So you print 400 and then print callable of X and callable of t. Well, X is callable, right? So if I scroll back up here, I want to show you the concatenator class. One of the things I didn't show you already is that there's a call method, right? So then if we go ahead and look at the call method right here on line 53. So to find call, it doesn't accept any inputs, but it just returns 6. So if we treat an instance of the concatenator class as a function, we're just instructing Python to return the number 6, right? But that would be an example of a callable class. If you say print callable of X and callable of T, you would get false because callable of T is false, right? 400 is not callable. But then if you say print callable of X and callable of Y, that would be true. That's this true here because the subclass concatenator class, it doesn't have a call method explicitly, but it would use the one from this. So both of those objects, both X and Y, would be callable. So hopefully that's clear to you. And then just another example, print callable of callable. So callable is callable, right? And then len. So len is a function which accepts an iterable and returns the number of elements in the iterable. So that would be true. That would be callable as well. So that would be this true here. And then print x, like the function x, and that would be 6. Print the function y, that would be 6, because that's what's instructed by the call method, as we talked about in a previous video. But if you just print the instance x or the instance y, then that would basically give you the string representation. Then we would have to go ahead and use the str method. So let's go ahead and first look at the str method from the concatenator class, because X is an instance of the concatenator class, right? So if you scroll up, and you go ahead and look at the str method, it says string representation of a concatenator object, and it looks like you just return me.myval. So here, instead of saying self, I'm just saying me, but it's just to remind you that you don't have to say self, but I just say return me.myval. So that would just show you the string. But then in the subclass, well, what's a string representation of subclass concatenator object? Well, that would be a string representation of the concatenator objects concatenated with good night. So there's two modifications to make if you're printing a subclass concatenator object rather than just a concatenator object. The first is that there's hello added onto the myval instance variable when the subclass concatenator object is first created. And the second is that when you try printing it, we instruct it to not only print that myval instance variable, but also the good night. So then you would just get, if you try printing X, you would just get cookies and, but then if you try printing Y, you would get hello, pasta, and good night. So hopefully that's clear to you. And then print of S, colon equals sunset. So now we can go ahead and review past 5 values. So here we have a variable called S. It's a string variable, print of S, colon equals sunset. Concatenator dot try concatenating of S. So let's go ahead and look for a class method or a static method in the concatenator class called try concatenating, which accepts one input. That's this one. And we already looked at this. And we said we accept this, we accept an X. And we concatenate pizza is delicious, right? So this data type is arbitrary, but it has to make sense within the context of the function. If you say plus equals a string, that implies that X has to be a string, right? And so we're just going to go ahead and we have that string sunset, right? And then we basically say concatenator dot try concatenating of S, right? And so then we're going to say this is an instance method, right? And then we go ahead and say, no, sorry, we don't say that yet. We say, okay, I'll try adding something on about pizza. Then we say X plus equals pizza is delicious. But then if we go ahead and scroll back down, we can compare that with what we actually get. So we tried running the try concatenating method and concatenating on the pizza is delicious. But then if we say print S again, we just get sunset. And that's the example of past 5 values we talked about in the previous video. And we said there are 3 solutions to that. You can either update an instance variable of an object, you can return a new value, or you could go ahead and change an element in a list with one element in it. Right? And so then what we're going to do is we're going to say X dot concatenate me. So basically remember that X is basically an object which holds on to a myval called cookies and, right? That's the value of the myval instance variable for X. It's cookies and. So then we're going to say X dot concatenate me. So let's go ahead and figure out what the instance method called concatenate me does in the concatenator class. It's an instance method that acts on the concatenator object, which successfully updates its myval instance variable. Okay, and then so then what you would do is you would say print this is an instance method, and then self.myval plus equals pizza is delicious, right? So we're going to go ahead and concatenate the pizza is delicious, and it's still a void method, right? It doesn't return anything, but it successfully does what the sunset was not able to do, right? And so then if you go ahead and say, you would just go ahead and get cookies and pizza is delicious. So I just want to show you the code, right? So if you say print X, you can see that the string representation of X is to print the value of the myval instance variable. And you can see that that was successfully concatenated, right? It was successfully modified to add on the pizza is delicious string. So hopefully that's clear to you. And then we could also say concatenator.concatenate object of Y. Okay, and so that would be a static method. And then so let's go ahead and see what that does. That would be very similar. That would be very similar, right? And so that would be a static method instead of an instance method. But instead of acting on an instance of the class, it just accepts an instance of the class and concatenates the instance variable for whatever you passed in. So I think I had a comment up here, or I said for a concatenator object, c.concatenate me has an effect similar to concatenator.concatenate object of C. So then this is just a static method which accepts a concatenator object rather than acting on the concatenator object and not accepting any inputs. But this will be a static method, and you would say my object dot myval plus equals pizza is delicious. So then again, if we go ahead and scroll down, I need to remember the line numbers. But then you would go ahead, remember when we tried printing Y before the sunset, we got hello pasta and good night. But then if we say concatenator.concatenate object of Y and then print Y, then we'll try adding on something. Then we get hello pasta and pizza is delicious, good night. Okay, because then we basically, because we added on the pizza is delicious to the myval instance variable, and then the str method instructs us to add good night on top of that. So hopefully that's clear to you. And then we could say print of network colon equals my network. So we just get my network. But then we're going to say print concatenator dot return concatenate of network. So we just talked about the first approach, the first solution for pass by values to update an instance variable, but you could also just return something new. So let's go ahead and look at the return concatenate method, right? If we go ahead and scroll over, that's a static method. So it's just called on the class, but it accepts a string and returns a string with text added onto the original string. So you would just say return concatenate of T, return T concatenated with pizza is delicious, right? So then if we scroll back down, we could go ahead and look at print concatenator dot return concatenate of network, and then you get my network, pizza is delicious. That's another approach that you have to successfully adding on something, right? You just return something new, and that works better than that sunset example that we saw like 5 minutes ago, which wasn't working well. And then you could also, the third approach is to just have a list with one element. So L equals the list something else, and then print L of 0, and then you just get something else. But then we're going to say concatenator dot concatenate list of L. So let's go ahead and look for the concatenate list method, right? That's right here. It's a class method. So that's why you have to have this little tag on it, right? This is not an input, but it's this little tag that you need with a class method. But otherwise, it functions pretty similar to a static method. The only other difference is the decorator that you use here. But you would say concatenate list of my list, this one input. Function which accepts a list with at least one element, the first being a string, and successfully adds text to that element. And say my list of 0 plus equals pizza is delicious. So then if we scroll back down, I think we're at line 112, right? So then print L of 0, we just got something else. But then if you say concatenator dot concatenate list of L, and then you print L of 0 again, you can see that that element in the list was successfully updated, unlike that little sunset variable, that little string variable that we had previously, right? We saw that the sunset method did not get updated, but this element in the list did get updated. What I also wanted to quickly do in this video is review some stuff about hex very, very quickly. I didn't leave as much time as I'd hoped, but to find my hex, or review hex of x and int of y for some int x or hex number y. So print of Barry equals 253, we just get 253, right? And then print int of Barry, we get 253. Print float of Barry, we get 253.0. Print length of string of Barry, that would be 3, right? Because it would be 253. The string has 3 characters. Print bool of Barry, that would be true, but print bool of Barry minus 253, that will be false, right? Print hex of Barry, what gives you the hexadecimal representation of 253. And then print hex of Barry minus 1, well, instead of 0xFD, you would just get 0xFC, right? It would just be this least significant digit. That would just be 1 less. You would get a C instead of a D. But print hex of Barry minus 16, well, instead of FD, you would get ED, right? Now, the more significant digit would fall back by 1 because you're reducing it by 16. And we said the hexadecimal numbers are base 16, right? Print hex of Barry plus 32, well, that would give you 1D, right? And then print hex of Barry plus 16 times 100, that will give you 73D. And then there's other examples, right? And then u equals 0xBA, so now we have a hex number, and then print int of u, well, then that would just give us 186. Float of u is 186.0. Print callable of u, a hex number is not callable, but print callable of a colon equals lambda potato bool of u. Okay, so it's the function that accepts an input and simply returns bool of this constant hex number u callable, and the answer is yes. Any function is callable. Lambda functions are callable, even regardless of whether they accept an input. Functions are callable. So print a of 725 and true, and that would go ahead and be that would be true here, right? Because we said callable of u is false, but then a of 725 and true would be true. Okay, and then u equals 0x00, print false or a of 328, and so then that would go ahead and be that would go ahead and be this. That would go ahead and be this false. I think I got confused here. So callable of u is false, and then callable of a would be true. Callable of a of 725 and true would be true, right? And then if you say print false or a of 328, that would be false, right? And then we can review ASCII. So CHR of x and ORD of y. So if we say AB equals CHR and ORD, so it's tuple unpacking again. So A of x would return the character if you specify a character encoding. B of x would return the character encoding if you specify a character, right? So if you say print B of the character 4, you get 52. Print B of the character $, you get 36, because those are the character encodings, right? That's what ORD of x returns. Exec of PRI concatenated with NT of B of M. So what is the character encoding for the capital M? And that would be 77, okay? Print a val of A of 73. So we said a val accepts a string and basically undoes the string, gives you the literal value of what's inside the string. So A of 73, what's the character with code 73? Well, it tells us that would be capital I. What's a of 33? Well, that would be exclamation point, and I wrote it as print eval of a of concatenated with 33 closing parentheses. So hopefully you can understand how that works. Print b of a of 33, that would be 33. Print b of a of 60, that would be 60, because we said the CHR and OR functions are sort of opposites or inverses. They do the opposite of each other. And then we could also go ahead and review set theory and dictionary theory. So remember that sets have shorthand notation for union, intersection, and set difference. So you could say my set one equals set of my tuple colon equals, then we have a tuple, but we're just going to convert it to a set, right? So the duplicate nines are going to fall out. Okay, and so then if you go ahead and say, okay, print, and then we're going to go ahead and say, my set two equals frozen set of 525. So then this will be an immutable set with only 5, 2 in it. You can't add or remove elements, and obviously you can't have duplicates either. So print my set one, you get 2, 3, 5, 9, 19. Print my set two, you get frozen set of 2, 5. Print my set one dot union of my set two, you get a set, a regular set. But if you say my set two dot intersection of my set one, you get a frozen set, because we said, if you remember, it's this underlying, it's what you call it on, that's what returns. So set dot frozen, set dot union or intersection of frozen set is a set, but frozen set dot union or intersection of set is a frozen set. So hopefully that's clear to you. And then we could go ahead and also return some other things. So then I could say print of my set two, like, and then you could have this vertical bar, and that's the same thing as union. And then you would get frozen set of 2, 3, 19, 5, 9. So it has the same elements as my set one dot union of my set two, but now it's a frozen set instead of a regular set. And then you could send print my set one and my set two, and then you would just get these two elements. And again, now it's a regular set instead of a frozen set, because you called my set one first. Okay, and then you could also have the differences between two sets, and you can go ahead and try examples of that, right? If you took all the elements in my set two out of my set one, you would just be left with 19, 9, and 3. If you took all the elements out of my set from my set one out of my set two, you would just be left with an empty frozen set, because the first thing that you used before the shorthand notation was a frozen set. So hopefully that's clear to you. And then we can also review dictionary theory. So remember, we said that dictionaries can only have immutable keys, like tuples, frozen sets, or frozen dictionaries, rather than lists, sets, or dictionaries. So my tuple equals A3 apples, it's a tuple. My frozen set equals frozen set of 6, 7, 6, 7, 6. So it's going to be a frozen set with 2 unique elements. My list equals 9, 5, true. It's a list. And then my set equals set of 7, 9, 7, false 0. And I think Python is upset because it said, oh, well, you don't have to write set of that. You can just write the set. Okay, but then anyway, it's going to function the same way. So we're here. And so then what we're going to do is we're going to say my dictionary, and then it's just going to have 2 key value pairs. So the keys are going to be immutable. So we're going to have the tuple and the frozen set. Okay, and then for the values, we're going to have the list and a set. Okay, so the value for the tuple is going to be the list. The value for the frozen set is going to be the set. And then we're going to say for s in my dictionary.item, so it's a generator we talked about in a previous video, and then we could say print of s, and that's just going to go ahead and basically print tuples, right? Where the first thing in the tuple is the key, and the second thing in the tuple is the value. That's how we talked about how the items generator, that's what we talked about how the items generator works. But then if you tried saying try other dictionary, and then if you tried making mutable keys and immutable values, it's okay to have immutable values, but then if you have mutable keys, then you could try printing the length of that other dictionary, but then you would go ahead and get a type error, and you could say can't have mutable keys in the dictionary. So hopefully that's clear and interesting to you from UMOSO 3. We'll talk more in the next video. Thanks for watching. Please subscribe.